Okay, now that you've seen me solve a problem, why don't you solve a problem? Okay? You have your equations up here. A basketball player is balancing a spinning basketball on the tip of his finger. The angular velocity, the speed of the ball, slows down from 18.5 radians per second to 14.1 radians per second. During this slowing period, the angular displacement is 85.1 radians. How long in seconds does it take for this ball to slow down? So with your neighbor, get a number. Get a number. Okay, does anyone have an answer they want to share with us? 5.22 seconds. Did anyone else get that? Good. That's the right answer. Okay? Let's solve it together. If this ball is spinning in this direction, then by right-hand rule for omega, we would have an omega vector pointing up. Now, by putting my initial omega in as 18.5 radians per second, I'm putting it in as a positive 18.5. That means I'm defining a coordinate system where up is positive and down is negative. A little bit later, the omega is still pointing up, but now it's only 14.1 radians per second. Now, during the course of this slowing down, the angle is going to go through 85.1 radians. We're looking for the time. That makes the alpha the who cares. That tells us which equation we should use. We should use the equation over there that doesn't have alpha in it. Now, before we stop caring about alpha, I just got to ask. If I did care, suppose I did, would that alpha be positive or negative? It would have to be negative because this wheel is slowing down and I'm calling my omegas positive. My alpha has to point opposite the omega. It would have to be a negative. But I don't actually in this problem care what alpha is. So let's find our time. The equation over there that does not have alpha in it is that second equation. So I would write delta theta is equal to 1/2 omega initial plus omega final, delta t. This is going to be 85.1. This is 1/2 times 18.5 plus 14.1, delta t, 85.1. This is going to be 32.6. Half of that is 16.3. And so delta t is going to be 85.1 over 16.3 or 5.22 seconds. Okay, see if your neighbor got that. If not, you know what to do.